What's up, Dilly?
What's up, buddy?
We had to move the plasma table back here, make room for the laser. So this is going to be our production lab for the next couple weeks while we get the fiber laser set up. So yeah, this is the fun stuff we do on our Christmas break. It's a new home. Yeah, for a minute. All right, but we're back here. Let's play with the blazer, guys. All right, here's the setup, guys. Got our ground clamp, the anvil from last week's video, some of this hard facing rod, safety glasses, welding shield, gloves, and our electrode. So let's head over to the machine. Some of you may be wondering what hard facing rod is, what is it used for, how do you weld with it. There is gas shielded MIG hard facing wire, there's flux core hard facing wire, and then there is stick electrode hard facing wire. They come in all sorts of crazy brands. This one's called Ultra Hard 60. Some of the other ones are like Super Hard, Magnum XL, you know, Hardness 5000. They all pretty much sound like they're owned by condom companies. If welding lasts more than 4 hours, please seek the attention of your nearest CWI. But with all that being said, you don't really want to build up multiple layers of this type of rod. It's not meant for like multi-pass welding like a 7018 would be. What generally happens is people get the largest electrode that they can handle. I tried to put it in the MIG welder, but I'm set up for 030 wire because we mostly do handrail and kind of finish type architectural work. And I didn't want to get the new drive rolls because the smallest MIG wire they had was 045, and it would have meant changing out my liner and the rolls and all that. So instead, we're over here at the Blazer. We're gonna hook this thing up on stick. So this Ultra Hard 60 likes to run, let's see here, AC or DC reverse polarity, meaning electrode positive. So right here we've got our electrode, which is positive, and over here we've got our negative side hooked up to the ground clamp. All right, you wanna know what kind of stuff hard facing is usually used on other than anvils? It is for sand and gravel pump impellers, shell buckets and loader lips, conveyor screws, plug mills, mixer chutes and blades, bulldozers, end bits, snowplows, shoes, cinder, and slag handling equipment. Pretty much stuff you need to make harder that's gonna wear a lot, so like screw conveyors, buckets, teeth, and anvils. So this is what we're gonna do. I got myself a 3/16 electrode, so a little bit fatter, and we're gonna lay one nice big solid mass of this stuff down on that top plate. And hopefully it doesn't take me another 2 hours to grind down like the last one did. My guess is this is harder rod, so it's probably gonna take 4 hours to grind down. But there's one way to figure it out, and that's to do it. So let's hook this sucker up. Need to turn on the Blazer. Yahtzee! You know what? My first passes with the MIG welder were kind of cold, and it didn't really warm up until the second or third pass, and then everything started sitting flat. Since I want to prevent as much grinding as possible, I'm actually going to go grab a torch real quick, and we're going to preheat this and hopefully get a better first pass, and that should lead to less grinding. All right, I can't find my lighter. There we go. One thing you're looking for when you're preheating is an indicator of how hot you are is water turns into vapor at 250 degrees. So as soon as you see this water start beading up and steaming off, you know you're at about 250. So that's just a good frame of reference. We want to be at least 250. I'd like to get to like 300 or 400, which is a healthy interpass temperature for some other welding processes. I'm not super familiar with this one, but hotter's always better with welding, in my opinion. All right, everything's fairly hot, so let's lay down this first pass. See how chunky and crumbly that slag is? And it's just peeling right off of there. It's sitting down pretty nice and flat. You know, fairly decent for what we're looking for. So let me go grab my brush and clean up this edge. That way we don't trap any of this slag, because we're gonna start stacking these welds all the way across here. Boom, 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 boom. And it was pretty nice actually. One rod got me all the way to the end perfectly. So let's keep cruising. All right guys, here on the horn, I didn't get any inclusions or porosity, at least, you know, before grinding, nothing rose to the top. And I think it's because I wasn't overlapping my passes nearly as much down here on the horn. On this top half, I stayed really good, like kind of a third to a half on the old weld, and then a half to 2/3 on the parent metal here. And then when I got here, I kind of missed my shadow line halfway through and started stacking these up a little heavier on top of themselves. So this could be why they say hard facing rod is not made for, you know, multiple passes. It's possibly when you start stacking it up on itself, it just has a bad reaction. But one note here is, you guys see this heat mark right here? We dumped a ton of heat into this thing, which means we should have a really nice cohesive top section here that's tied together really well. You'll also notice, because of the heat, we ran over we were at 220 amps. All this is sitting really flat, so it should give us, you know, the smoothest grinding experience possible. But that's the next step of this. All right guys, wish me luck. I'll probably see you in about 4 to 5 hours. Okay, this stuff grinds a little faster than I thought it would, but it's not throwing sparks, because it's probably an odd mix of metals. And it's making some funny smelling smoke, so I'm gonna go grab my respirator. That feels suspiciously a lot like work, guys. All right, guys, I'm really not that happy with this. As I started grinding, I found a bunch of porosity. This is hot garbage, fellas. I'm starting to suspect that it's really because I'm stacking these passes too closely. You notice out here I did these 2 outside welds first. And oh, there's a little bit of porosity right in here too. So what I'm going to try and do is grind out these pinholes as best I can and fill them back up with some good metal. But the other thing that I noticed is some cracks. So I don't know if you guys can see right there. There's some cracks starting to develop as this was cooling, and it's across more than one weld. You can see another little crack popping up right there, and it goes through 2 or 3 of the passes. So my guess is that this is cooling at a different rate than the apparent metal and causing it to crack. Kind of like when you weld cast, they both contract at different rates. You end up with cracks in your welds. I just don't feel super confident about beating on this thing. I think you're gonna have a lot of chips flying off. So let me try and gouge these out, and we'll try filling them in with some healthy metal again and see what happens. All right, let me show you what I'm seeing here. See, the more I grind it, the more porosity just starts showing up. So this whole thing is just full of pinholes. So I'm gonna try and run a pass over the top here. I got almost everything chewed out over here. So let's see if just welding over this is gonna help us out, or we're gonna be right in the same spot again. All right guys, that's pretty much what I expected. There's the fresh weld that I just put in that gouged out area, and porosity just popped right back up. And then also where I had this pretty much all cleaned up back down to the apparent metal, I just ran another stringer pass, and as soon as I got about, I don't know, an 1/8 inch down, boom, there's the porosity again. So I can't recommend hard facing this whole anvil. It's just really not the answer here. So I'm gonna have to go back to the drawing board, see what else we can figure out. We don't have the perfect solution for a DIY anvil. I'm not really sure what to try next, but I might go fill it back up with some MIG wire and see if maybe MIG wire, hard facing MIG wire, maybe we can get rid of some of that porosity and maybe the hardness underneath the MIG wire. Let's see if we can cover up some of this porosity with the MIG gun. Oh, it's doing that weird pingy cooling thingy. Isn't that crazy? The wild stuff. I got this all filled back up with some regular old 70 series MIG wire. I welded it all out, 29 volts and 585 inches a minute. Really put the heat to it. And I really watched as it dug with the arc force right before it filled. A lot of porosity opened up in here. This was a mess. So really the test is gonna be whether the hardness underneath, even though porous, if it's going to add any sort of bounce to this top layer now. Basically all I did was chase pinholes. There wasn't any pinholes. I didn't really put any MIG wire back in it, but this was riddled pretty much the whole thing. This first pass or two was actually pretty clean, but as soon as we got over here into this stacked mess, it really started having problems. So let's grind it down and see if we solve some of our porosity issues. Another hour and a half chasing this all down, but we got it good enough where we can do a couple little bounce tests, because I'm really curious to see if that hard facing layer underneath here is adding any sort of hardness, bounciness, strength, goodness, all these tools, and never a tape measure. Nope. It's like we didn't even do the hard facing at all. Maybe there's a reason you guys buy an anvil off the shelf. This is harder than it looks. One other option.